All right, so you're at the Hamfest, you're walking around the Boneyard and you find this used antenna switch that you're interested in getting. But before you put it in line, how do you know it's good? Stick around. Let's talk about it. Hey everybody, Tim here, GraymanPOTA, amateur radio call sign November Whiskey 9 Foxtrot. Well, that is the question. Now, if you're on a limited budget, you're out at a Hamfest, you're in the Boneyard and you find an antenna switch, and it could be anything, right? How do you test this thing? How do you know that it's good? The nice thing about the Boneyard is you can find a lot of used equipment in there. The unfortunate thing is you don't necessarily know the condition of that equipment. I'm always a little hesitant. If you have the budget and you can buy new, buy new. But sometimes components are pretty expensive. It may be outside of your budget and you have to go used. So the simple way of testing something like this is to actually use a couple pieces of test gear, inexpensive test gear that you should already have on hand. One of those would be an inexpensive multimeter. The other one is an inexpensive NanoVNA. So real quick, how do you test this kind of stuff? Well, obviously the first thing to do is make a good visual inspection. So let's go over to the bench. Okay, so we have the switch here on the bench. Well, in this case, it's an AB switch. So we would either take our input of our radio out to two antennas or flip it around and share one antenna between two radios. But either way, you know, quick visual inspection goes a long way. So if you flip it over, now I already took the back cover off of this one, but we can look at it. We can see, is it clean on the inside? Are our electrical connections in good shape? In this case, because it's isolating, we can see here as I rotate the switch, and this switch is tight, which is another thing that we want to look at. We want to make sure that everything is in good working order when we do this. So as we look here, we can see that the switch is tight. There's tension. It's not sloppy. As we move from position to position, this piece of metal here that goes between the center pins on the three ports, when we go to one position, it is now touching, making an electrical pathway between those two. But then the other side is now pressed up against the outside of the case here. So it is grounding the center pin to the case. We flip the sides, we see the opposite here. This strip now touches the center pin, and this one is grounded. If we kind of just poke here, we see that there's good tension against that, which makes sure that we are getting a good solid connection up against the center pin here. We flip the switch, we do the same thing. We can poke there and see that it has good connection. So that's the first step, a good visual inspection, just to make sure that everything looks good. Now you'd also want to make sure that there's like no corrosion or other things like that, signs that it has been in the weather. Weathering does cause corrosion. I'm not sure if this particular switch is rated for outdoor, but as you know, antennas have to be out. Well, they don't have to be. Antennas are generally outdoors, and with that comes rain, snow, the elements. So once again, just visually inspecting everything to make sure it's good. And now we have two forces that come into play in amateur radio. We have resistance, which is DC, and then we have inductance, which is also resistance, but it's in the form of AC or alternating current. So when we key our microphone and we transmit, we are modulating or alternating our current. It's shifting up and down. So what we need to do is kind of think of this in two different ways. DC, and think back to high school. You've got a long hallway. Your hallway has a width. You have kids that need to move up and down that hallway. They're all moving one direction. Now, based on the width of that hallway, if you start putting impediments in there, people standing in front of a locker, gathering around, it slows that flow of movement. That's essentially, in a nutshell, DC resistance. You can shrink the size of that hallway or expand the size of that hallway, and then that allows or reduces the flow of kids down that hallway. That is an easy understanding or representation of DC resistance. Now let's take impedance. And I'll think of that same hallway and think of those same groups of kids that might be gathering around a locker, and you still got all these kids that need to go down this hallway in between classes. Well, now let's add another variable in there, and we're going to call it ballroom dancing. So in order to get from one end of the hallway to the other with kids standing around, now you have to dance your way from one end of the hallway to the other in an organized fashion. Well, that's essentially what happens when we key the transmitter and we start oscillating our signal on a specific frequency. Two quick, easy ways of kind of understanding that. So ballroom dancing and just straight empty hallway. Hopefully those two will kind of to help in here. So the first thing we need to do is go back to the bench here. We're going to take a look at our switch, and we are going to use a standard multimeter. I've got the Testament here, and this is a fairly inexpensive one. I think it's about sub $20. Okay, to test the resistance, what we want to do is put our red lead on the center pin of the input, and we're going to go to the port A output center pin with our negative lead. And we've got the tone, that means we have continuity, but also, as you can see, we have zero resistance, which means that is good. Now, because this port A is selected, what we want to do is check port B to see if we have any continuity at all. Now what that does mean is that there is no pathway. Now we can flip the switch to port B and do the same test, center pin with the red positive lead on the input and the negative lead on the input or center pin of port B. And once again, we have a tone, which means we've got continuity, and also the meter read 0, which means there's no resistance. Now there could be some resistance, some minor resistance, but ideally you want that number to be very, very, very low. Single digits would not be a big deal. Now what you need to do is make sure the shielding side is there, and we should be able to test the shield of the input to port A. Same thing, we have continuity and a tone. Let's test the shield from the input to port B. Now the one thing that I had talked about when I had this flipped over here is that this metal strip is grounded up against or pressed up against based on which port you've got selected, the shield here. So what that should do is ground the center pin to whichever port is not being used. So what that means is that the center pin in this should be grounded to the frame or of the switch for whichever port is not being used. That way, if something comes into it that's on the center pin, it just gets grounded and it doesn't interfere. So let's test that real quick. So if we go to the shield on the input, and because port B is selected on the switch, if we go to the center pin and test that, that is also grounded. So the same thing should be true if we select port A and then go to the shield of the input and then test the center pin of port B. At this point, port B should be grounded. So we've done our visual inspection, we've done our electrical DC continuity inspection of the switch. So now that third test that we need to do is impedance. Remember, impedance is something that you really only see once you are transmitting. Once you're introducing an RF signal, an oscillating signal into the switch. What I've got here is a NanoVNA. And once again, another piece of inexpensive test gear that I recommend that you get. The other thing that we're going to need for this is a dummy load. Now, the dummy load that I have here is a little bit larger one. It is geared to support, I believe this supports up to 1,000 watts. It's a little bit larger. I am going to use it to create a 50 ohm load. Now we're using the NanoVNA, which is only going to produce a small output voltage, sweeping a frequency range. And we could do this with essentially a 50 ohm terminator piece of kit to have. A dummy load would probably be more applicable for a broader spectrum of things that you would want to do. All right, to get started, what we need to do is go ahead and get our NanoVNA out. Now, I'm going to assume that you know how to use one, that you've got the calibration set, and what we're going to do is basically use it to look at standing wave. Now, we're going to use that standing wave ratio kind of as a guide to measure the impedance. Now, there isn't a specific impedance measurement with the Smith chart portion of the NanoVNA, but that's kind of a little more complicated than what we need here. A simple standing wave to ratio measurement will give us the information that we need. Now, everything is based on a 50 ohm load, and you can look at that standing wave ratio, and we want to see 1-to-1. Maybe depending on the measurement here, the sweep, how wide of a stimulus you put in. In this case, I'm going to put in 0 to 30 megahertz, which is basically the entire HF band. So there could be some points in this dance where our standing wave might shoot up a little higher, a little lower than 50 ohms. But remember, a measurement, a standing wave of 1-to-1 is I'm measuring 50 ohms and I'm expecting 50 ohms. If I have a 1.1-to-1, I am measuring 55 ohms and I'm expecting 50 ohms. 2-to-1, I'm measuring 100 ohms and I'm expecting 50 ohms. So that's kind of how the standing wave ratio works. But let's go ahead and go back to the bench and get started. So we will need some cables to do some tests with. So I've got just a few jumper cables here. I'm going to go ahead and plug one side into the input of the dummy load. And I'm going to put this on the outside, or actually port 1, or port A of the switch. And then I'm going to, on the second cable, I am going to connect this to port 0 on the NanoVNA. And I'm going to put this on the input side. Once you have the NanoVNA connected, we'll need to do a couple things. We'll need to make sure that our stimulus is set for what we want to span. So our starting frequency in this case is going to be 1 megahertz. Our stop frequency is going to be 30 megahertz. So we're doing a 30 megahertz span. So basically the entire HF band. That's where you would use this in. If you were going to use this on a 2 meter, 70 centimeter antenna, you would need to make sure your stimulus is in a frequency range that it's appropriate for what you are looking for. For the markers, we just want to make sure that marker 1 is enabled. And for marker 1, we are going to format for SWR. We can move our marker across the sweep here from 1 megahertz all the way up to 30 megahertz. A little over a 1.1 to 1. So somewhere there across there, we are 55 ohms of impedance across the thing. Now let's switch it over to port B. Now you can see when I moved it to port B that our impedance changed dramatically, our sweep changed dramatically. Well, what that means is that there's an open there, and that's what it should look like. So while it's on the selected port and it's connected, we see that we've got almost no impedance, and that's what you want. You want 50 ohms of impedance, or as close to 50 ohms of impedance as possible. So let's move it over to the other port. Okay. Now, as you can see, now that we've moved it over to the other port, we're back to, we have a high impedance on port B, but port A is selected, right? So we are seeing on the screen that we are getting our high impedance. Now let's move the switch to port B, and immediately the impedance drops back down to 50 ohms. So that looks good. That is what is expected. So based on the measurements that we just got, I would say that I would be comfortable in inserting this piece of used gear into my setup and feel that I could relatively operate without any issues. So hopefully this helped you out. If you have questions or comments, please put those down below. I'll have links to all of the stuff that I had in the video today, and also to a what I would say an inexpensive, good dummy load to have on hand so you can do this testing yourself. Hopefully this helped out. If you liked this video, please hit the like button, share this content with your friends, and if you haven't done so already, please subscribe to the channel. If you're interested in supporting the channel, I have memberships, and I also have merch available. And until we have an opportunity to meet on the air, I have a video right over here that you might be interested in.